It was an otherworldly time when, in a moment, the Andromeda cloud transformed into the Andromeda universe. For a long time, perceptions made from Earth were the only way we knew how the Andromeda Galaxy worked. With the assistance of better technology and the launch of the James Webb Space Telescope, however, our knowledge has grown beyond all measure. Now, things are about to change because the James Webb Space Telescope has detected signals from the Andromeda Galaxy that are exceptionally startling. Scientists are still trying to figure out what these signals mean. Astronomers are both intrigued and curious about them. But what do these signals truly mean? The most significant question is, why are they making scientists so concerned? Just 2 minutes ago, the James Webb Telescope shut down because it received warning signals from the Andromeda Galaxy. Astronomers once thought the Milky Way was the entire universe before we could see very far into space. This lack of understanding was largely due to the fact that scientists didn't have the right instruments to observe different galaxies and individual stars. However, when we discovered the Andromeda Galaxy, everything changed. It was the first indication that the universe is much larger than the Milky Way. During the 1600s, Galileo Galilei's groundbreaking work with optics revealed what the Milky Way truly looked like. He saw that the Milky Way contained a vast number of stars, which contradicted the idea that it was the most significant structure in the universe. In the 1920s, Edwin Hubble used the Hooker telescope to observe distant objects beyond the Milky Way. This changed everything. It was Hubble who first realized that these moving objects in space were galaxies other than the Milky Way. The Andromeda Galaxy, or M31, was one of them. Abd al-Rahman al-Sufi, a Persian scientist, first wrote about the Andromeda Galaxy around the year 1050. However, this was the first time we saw it through a telescope. Astronomers were finally able to observe and understand what Andromeda was really like, thanks to technological advancements in the 20th century. Andromeda is a cloud of gas and dust consisting of an exceptionally large collection of stars, similar to our own Milky Way. Our companion in space is about 2.5 million light-years from the Milky Way. The way we study Andromeda has changed significantly since its discovery, going from ground-based telescopes to space telescopes like Hubble and the James Webb Space Telescope. We have come a long way, and with each new technological advancement, we have reached new heights and gained more knowledge about the Andromeda Galaxy. Given that we now understand more about its composition and structure, Andromeda has become a standard for studying how galaxies form and evolve. This has provided us with valuable insights into the workings of the universe. Scientists believe that studying the relationship between Andromeda and the Milky Way is crucial to learning more about the universe. This is particularly important because, in about 4 billion years, the two galaxies will eventually collide. Although research and studies have progressed, the James Webb Telescope recently received a signal from Andromeda that has alarmed scientists. Researchers around the world are puzzled by this unsettling signal, leading to questions about its origin and meaning. The advanced sensors on the James Webb Telescope have detected unusual activity at the heart of Andromeda. The signal sent back to scientists presents results that differ significantly from previous observations, intriguing researchers worldwide. The signal suggests that major events are occurring within the galaxy, possibly related to its massive black hole or other, yet undiscovered phenomena. One of the most recent discoveries is that Andromeda's mass may be much greater than the Milky Way's. This challenges our previous assumptions about the relative sizes of the two galaxies. The James Webb Telescope has also captured incredibly detailed images and spectra of Andromeda, revealing how new stars are formed and the chemical composition of those stars. This new data is crucial in understanding how galaxies change over time and what conditions might be suitable for life. The telescope data also indicates that Andromeda's active galactic nucleus is becoming more active, which will impact its surroundings and determine how the galaxy will be structured in the future. Experts are also investigating how mysterious dark matter is distributed throughout the universe by studying its gravitational effects on stars in Andromeda. This research should help us better understand how dark matter influences the physics of the cosmos. As it stands, one of the biggest mysteries in cosmology is dark matter and its role in the evolution of galaxies. Recent discoveries made by the James Webb Telescope have sparked numerous studies across the globe as astronomers attempt to unravel the true nature of Andromeda. We now have more information about the galaxy's past and future, thanks to newly uncovered data. So what do these various studies tell us about the Andromeda Galaxy? There are some astonishing things about Andromeda that set it apart from other galaxies. People are amazed by how enormous it is. New estimates place its diameter at about 220,000 light-years, making it one of the largest galaxies in our local group, possibly even larger than the Milky Way. Its immense size accounts for its mass, as it consists of around 1 trillion stars, which is more than our own galaxy. Scientists are also fascinated by its structure. Andromeda differs from most spiral galaxies because its central bulge and dense core are surrounded by rings of dust and gas, making it an exceptional site for ongoing star formation. One of its most intriguing features is its core, which has a double-peaked emission structure, suggesting the presence of a supermassive black hole similar to, but not identical to, the one in the Milky Way. This provides crucial data about these massive objects that consume matter and shape galaxies. Andromeda is also surrounded by a vast halo of stellar debris, spanning hundreds of thousands of light-years and consisting of stars, planets, and globular clusters. This stellar halo tells a fascinating and comprehensive story about the galaxy's formation and history. The 460 globular clusters discovered in Andromeda also provide valuable insight into how stars form in their early stages, helping scientists better understand the evolution of star clusters and galaxies. By piecing together the mysteries of Andromeda, astronomers are coming closer to understanding the role of dark matter on a cosmic scale. But one question remains: how can they explain its enigmatic nature and its role in galactic motion? Andromeda also stands out for another reason. It has satellite galaxies orbiting it. More than 20 smaller galaxies make up its halo. Some of these satellite galaxies are losing their stars and gas due to tidal forces. Nearby dwarf galaxies are being pulled in and eventually devoured by the larger Andromeda Galaxy. This shows that cosmic evolution is dynamic and demonstrates how galaxies grow and interact with each other over time. So, what lies ahead for the Andromeda Galaxy? Both astronomers and those fascinated by the cosmos are keen to understand its structure and movement. Andromeda's evolution suggests that it may transform from a spiral galaxy into a ring galaxy. There is evidence of a process that could lead to other intriguing formations. After the collision, the newly merged galaxy, sometimes called Milkomeda, will look vastly different from either the Milky Way or Andromeda. The spiral structures of both galaxies will be disrupted, giving way to a more elliptical or irregular form. The gas and dust within these galaxies will mix, fueling a new era of intense star formation. However, over time, as the gas is consumed by newly forming stars or ejected into space, star formation will slow down. The galaxy will gradually settle into a more stable state, resembling the giant elliptical galaxies observed in other parts of the universe. One of the most fascinating aspects of this merger is the fate of our solar system. Scientists predict that, while the chances of direct collisions between stars are extremely low due to the vast distances between them, the gravitational forces at play could alter the solar system's position in the galaxy. Some models suggest that the Sun and its planets might be flung into a more distant orbit, placing our solar system on the outskirts of Milkomeda. Alternatively, the Sun could be drawn deeper into the new galaxy, where the increased stellar density might lead to more frequent close encounters with other stars. Such encounters could disrupt the orbits of planets, possibly even ejecting some from the solar system entirely. While Earth itself is expected to survive, the long-term stability of its orbit is uncertain. By that time, however, the Sun will already be well into its red giant phase, making Earth uninhabitable regardless of the galaxy's transformation. Beyond our solar system, The Andromeda-Milky Way merger will have profound implications for the entire local group of galaxies. Smaller satellite galaxies that once orbited either Andromeda or the Milky Way may be drawn into the newly formed Milkomeda. Over billions of years, this process will reshape the structure of our cosmic neighborhood. Meanwhile, astronomers will continue studying Andromeda in detail, using advanced telescopes like James Webb and its future successors. They aim to uncover more secrets about Andromeda's black hole, its past galactic interactions, and the mysterious dark matter halo that surrounds it. Understanding Andromeda's evolution is not just about predicting its future. It's also about learning how galaxies grow, change, and interact across cosmic time. Every new discovery brings us closer to understanding our place in the vast, ever-changing universe. One day, humanity may even develop the capability to explore Andromeda up close, either through robotic probes or, in the distant future, interstellar travel. If intelligent life still exists in the Milky Way by the time of the Great Galactic Merger, it may witness a breathtaking event unlike any in human history. Two galaxies blending into one, reshaping the night sky forever. The Andromeda Galaxy has long been a source of wonder, mystery, and scientific inquiry. As we continue to study it, we not only gain knowledge about its past and future, but also deepen our understanding of the cosmos itself. What other surprises does Andromeda hold? Only time and continued exploration will tell. Energy particles arriving at Earth could prompt enormous radiation getting past our atmosphere. A conceivable rise in radiation levels could be harmful to the world's ecosystems, as it might accelerate changes in individuals and reduce biodiversity. The merging of black holes could alter Earth's orbit or axial tilt, likely affecting the way human settlements are distributed. One effect of climate change seen worldwide is its impact on biodiversity and ecosystem structures. Some species may thrive in the new environment, while others could become extremely rare or even extinct. As clouds of gas merge and compress, new stars will likely form. If this process occurs near our solar system, radiation from these young stars could alter the climate, significantly impacting temperature and entire ecosystems. These events shape the grand narrative of how the universe evolves, but understanding what happens after such impacts is equally important. Events that took place billions of years ago continue to shape the world we live in today. It is even possible that humanity may one day exist elsewhere in the universe. Investigating the Andromeda Galaxy appears to be key in understanding the evolution of our own galaxy and its future. Differences between Andromeda and the Milky Way help refine models of galactic movement and transformation. Re-evaluating Andromeda's size and mass has provided new insights, challenging previous beliefs. Recent data suggests that Andromeda and the Milky Way are roughly the same size, contradicting earlier assumptions about our galaxy's role in the local group and its gravitational influence. Currently, the Milky Way appears to be a barred spiral galaxy, but its interaction with Andromeda, an inevitable event, could change its structure. Observing Andromeda's evolution helps us understand how large galaxies transform over time. By tracking Andromeda's current position, we can predict where and how the collision with the Milky Way will occur. This event will alter the rate of star formation, as well as the distribution of gas and dust within both galaxies. New technologies in cosmology have enabled the creation of advanced models, expanding the scope of astronomical research. Every scientific breakthrough builds upon the previous one. The journey began with the invention of the telescope in the early 1600s, allowing scientists to observe Jupiter's moons and the phases of Venus. As telescope technology improved throughout the 19th and early 20th centuries, astronomers discovered new celestial bodies, such as Neptune, and gained a deeper understanding of the universe beyond Earth. Despite atmospheric and light pollution challenges, ground-based telescopes have made remarkable discoveries. The launch of the Hubble Space Telescope in 1990 marked a significant leap forward. Hubble provided an unobstructed view of the cosmos, eliminating Earth's atmospheric interference and offering unprecedented clarity. It has deepened our understanding of black holes, the age of the universe, and the nature of cosmic expansion. Other space telescopes, such as the Chandra X-ray Observatory and the Spitzer Space Telescope, have further contributed to our knowledge. These telescopes observe the universe in wavelengths beyond visible light, allowing scientists to study phenomena such as cosmic microwave background radiation, star-forming regions, and remnants of supernova explosions. However, dark matter remains one of the most mysterious and intriguing subjects in astrophysics. It accounts for approximately 90% of a galaxy's mass, yet it is invisible and cannot be detected using conventional methods. Instead, dark matter's presence is inferred through its gravitational effects on visible matter, radiation, and the structure of the universe. Observations of dark matter in Andromeda indicate that stars on the galaxy's outskirts rotate at speeds comparable to those in the center, contradicting earlier theories. This suggests that dark matter and other unknown particles influence and surround the universe. Andromeda's halo contains a vast amount of dark matter, extending well beyond its visible stars. This halo significantly affects the movement of star clusters and satellite galaxies within Andromeda's gravitational field. Scientists have studied how orbital dynamics influence the distribution of dark matter within a galaxy. Research indicates that Andromeda's dark matter halo is not only immense, but also extends far into intergalactic space, covering over 1 million light-years from its center. The nature of Andromeda's dark matter differs from conventional expectations, with its mass concentrated near the galactic core and dispersing outward. This influences star formation, the structure of spiral arms, and the rate at which new stars emerge. Dark matter is believed to be a primary force behind galaxy mergers and interactions, shaping the final outcomes of these cosmic events. One of modern astronomy's most significant goals is to determine what dark matter is, as this could lead to a deeper understanding of the universe's composition and evolution. As Andromeda and the Milky Way approach collision, their massive dark matter halos will also interact. These invisible halos will be pushed and reshaped by the merger, playing a crucial role in determining the final structure of the new galaxy that emerges. Observations of Andromeda have helped scientists fill in the gaps about how galaxies formed and evolved in the early universe. Astronomers analyze galaxy structures in detail to understand the subtle processes that shape them over billions of years. When two galaxies merge, spiral arms form, central bulges develop, and the overall structure is transformed. Studying Andromeda provides crucial data for refining cosmic models, including those predicting the scale and expansion of the universe. By measuring the chemical composition of Andromeda's stars, astronomers gain insights into stellar birth and death processes, as well as the chemical enrichment of the universe. With these discoveries, we now have a clearer picture of nucleosynthesis and other processes that govern the early evolution of the cosmos.